Questions that we're asking are, what is the toxicity of some of the PAHs that are found in crude oil, that are specific to crude oil, that we really have little to no toxicity information on. Without that information, we can't really form any kind of rational risk assessments, whether those be used for human health or animal health. It's important because right now our risk assessments, whether they're human or animal health, are based on PAHs that we know quite a bit about, but they are not the only PAHs found in crude oil. So we need to find out more about these alkylated PAHs that are really specific to crude oil that might end up in our food chain or the animal food chain that could pose a health risk that we don't know much about right now. So we're a team of 4. There's 3 of us that are toxicologists by training. One of us is a receptor toxicologist, Dr. Chuck Miller at Tulane University. I myself and Mark Wilson are genetic toxicologists, both at Tulane as well. And we're working with an environmental chemist, Dr. Ed Overton at Louisiana State, who's helping us characterize oil so we can get a better handle on what sort of environmental concentrations of these alkylated PAHs are, so we can make our studies more relevant to what we find in the environment. So we're using a few bioassays. Dr. Miller uses a yeast-based aryl hydrocarbon receptor system. So PAHs, at least our classical knowledge of PAHs, is they enter a cell, they bind the aryl hydrocarbon receptor. This receptor then translocates to the nucleus of the cell and turns on a suite of genes that are coding for enzymes that metabolize those PAHs. In that metabolic process, they can form reactive metabolites that bind to DNA and that can ultimately end up as mutations in DNA, and that's part of the process that we all generally accept as necessary to lead to carcinogenicity. So we're using a cell-based system, mammalian cell, human cell line, that actually Dr. Miller's data from his receptor information will feed into our system, so we prioritize which of these alkylated, unique, petrogenic, oil-based PAHs need to be fed into our system, and do they upregulate these metabolic processes in genes. And then we have a mutation assay in the same cell line, so we can actually look downstream to see if any of these alkylated PAHs actually form mutations in DNA. So we can start to kind of fill that gap from exposure to carcinogenicity. We're a little upstream of that, but that's kind of what we hope to do with this assay, is prioritize those compounds. Yes, is actually to build a priority list going forward, such that if we need to do further testing regarding whether or not these PAHs can lead to outcomes, adverse outcomes like cancer, we can hopefully provide a prioritized list for testing through our 2 bioassay systems. And then with our chemist, we are interested in again, informing the PAHs that we use for testing and any kind of mixtures that we're interested in testing, because we would like to extend this to mixtures to PAHs, using his data on environmentally relevant concentrations that we would use in environmental mixtures to feed that system for further testing.